Right, we get on to some of the meat now. Section 6, Anchorage. Now, this is the most crucial part of bouncy castle operation. I cannot imagine the tragedy that we had in Tasmania. I can't imagine having to go through it as anybody involved in that situation. Recently for this video anyway, judgment came through from the court, and there was two factors involved. One said that no pegging would have held down because the dust devil, I think it was called, basically a local tornado, came through, and the wind for that was more than anything was going to hold, so it was an accident. Another part of it said that the operator had only put in 4 pegs instead of 8, so it wasn't held down. Something that operator's going to have to live with, and something that we all live with. Do you put all the pegs in? Should I have ordered more anchor points on my inflatable? Should we have done this? Should we have done that? Should we have had longer pegs? Should we have put pegs in differently? Should we have done this? Should we have tested the soil, etc., etc.? Anchorage is a major point. The Tasmania tragedy, if it has... it's not good. If it has any benefit, any good things to take away from it, it's like things, it's made people here, at least in New Zealand, a lot more aware of what the wind can do to an inflatable, and it's made my job easier in terms of saying no to people because it's too windy. We get less of the "oh, she'll be right, mate, don't worry about it," etc. And if I say no, it's too windy, they are more likely to say, "Yep, you're the expert, we understand." Again, it's difficult because people have shelter belts and all sorts of things, and the wind conditions are different in different places, etc., etc. It is difficult, but at least it has made people aware of the dangers which are involved. Just wish it hadn't taken a tragedy to make people aware of that. So, Section 6, Anchorage. It says that sufficient anchor points will be provided to enable stability and maintain restraint under the manufacturer's stated operating conditions. So it could be that a manufacturer says, this shouldn't be used in winds greater than 10 kilometers an hour. That would be very low. It shouldn't be used there, and that would supersede anything said in this standard, because if the manufacturer says it's not for windy conditions at all, then that's what you should operate to. In my experience, manufacturers don't tend to specify that much, or if they do, they just specify it so that it's ultra safe and you can't operate not operating in 10 kilometre an hour winds. It's just silly, but they'll write in that way. It clears them of any responsibility. The user manuals such that I have, you don't get a user manual with every bouncy castle because it's just not that difficult to use a bouncy castle, tend not to be very precise, tend not to be specific to each piece of equipment, and so really not that useful. So if you ignore the user manuals, or in the absence of user manual, I should say, not ignore them, but in the absence of user manual, the wind speed for which an inflatable shall be designed shall be not less than 40 kilometers an hour, 11.1 meters per second. So if that is the case, then it is safe supposedly, to operate up to 40 kilometers an hour winds, because if the unit complies with AS 3533.4.1, because that is the wind speed that the anchorage points are designed to take. I have to say, 40 kilometers an hour is really strong winds. I wouldn't want to be putting a bounce castle up in those winds. Really not. Now, the number of anchor points that you use, I mean, obviously, you don't have to peg every single one in, again, because what happens if you've asked for extra ones to be put on, or sometimes there's a anchor point underneath the blower vent, but there's two blower vents, so the one that you use for the blower, you don't put a peg under that one, you put it on the other one, perhaps something like that. There are also times when anchor points are very near where children will be getting off or getting on, and you go, I'm not going to put that one in because it's unlikely that's where they'll stub their toes or whatever. But they give a formula for calculating how many points. I've taken that formula, I've used it, and produced a spreadsheet of how many pegs, and I am surprised about how few. Really shocked. In most cases, for most bouncy castles, I shouldn't say most, but lots of the ones we've got, bouncy castles, the answer is none. One. It does say that you'll have at least two as a minimum. So, it covers itself like that. But just two. Recently, we had to put up our big caution slide. It's 22 foot water slide. It's enormous. And it was up in winds where the forecast had said the winds were going to be about 35. Now, that's usually my cutoff, somewhere around there. But you've got to have a cutoff for a reason. If the cutoff is 35, would you cut off for 34? Well, if you do, then 35 isn't the cutoff, 34 is, etc. And you can see yourself working yourself down until you really are going too far down. I did an estimate of the side area of our slide and the wind speed, and it recommended 5 pegs. It wasn't me, it was the boys, put in 12. Actually, it was more than 12. On one side, 12 on the other, however many on the back, can't remember. The front, not so many, because if you think about it, slide's very thin and the front there, so you have to rely on the side pegs doing most of the heavy lifting for that one. Now we get to the meat of it. Okay. Anchorage system. So this is 6.2 on the AS3533.4.1. Where you have not secured the inflatable down to the floor with ground anchor stakes, pegs, in other words. So it's saying, if you're on concrete or paved areas or whatever, I think I can read this bit. The total anchorage system shall be designed and detailed to withstand the same forces as though it was secured with ground anchor stakes. So the weight bags, usually weights of some description, that you put on that bouncy castle must withstand the same horizontal forces and vertical, but horizontal forces as pegs. Even when it's inside? Doesn't say. It does say when you're secured with ground stakes, so this applies to the weights as well, but we're talking about ground stakes, each stake shall withstand a minimum horizontal force of 1.6 kilonewtons. It then says that's equivalent to 160 kgs force, but that would be taking gravity as 10. It's 9.60. Oh, 9.80665. Shh, don't tell them. Oh, they know. They just chose not to use it. 1.6 kilonewtons. So roughly the equivalent of 160 kgs pulling sideways. Imagine that for weights. And you go, oh, I've just got to use 160 kg weight. You go, no, you've got to withstand a horizontal force of 160 kgs. So you're dealing with friction on the floor. Well, a quick search of friction for PVC, rubber, or whatever, to concrete, for example, details a coefficient of friction of around about 0.5. If it's a 0.5, then each weight needs to be at least 320 kgs, 1/3 of a ton. Let's be generous and say the coefficient of friction is good because you've put some sort of rubber thing, non-slip grip, whatever. 0.8 or something like that. You're still dealing with over 200 kgs at each point. So if you put a small bouncy castle on the road and you had to put at least 2, because it says there's a minimum of 2 anchor points per side, normal operation. So a small bouncy castle on concrete, that would be 8, if it's square design, that would be 8 weights. Let's say each one is, let's be generous with the coefficient of friction, say it's 1. Not 1, it's never 1. Let's say it is 1, then you would have to have 8 times 160 kgs. 1.2 and a bit tons. You're transporting an 80 kg castle to somebody's house or venue or whatever, and 1.2 tons. No, that isn't going to happen. No, that's never going to happen. It then goes on to talk about the anchor points being able to withstand a horizontal and vertical force simultaneously, and that's covered in the appendix, and we'll do a separate section on that. It also talks about the fact that some anchorage points or systems might be guide ropes. So it talks about the difference between them and just putting ground anchor stakes, which I think is the kind of most. If you have slides, you definitely have guide ropes around the back. I've got a few bounce castles which I've got a few guide ropes on, which I am very thankful for. Just on some windy occasions, just stops the top flapping around a bit. But most just have ground anchor points. It says the anchor stakes shall be fit for purpose and not fall apart. That's all good. Simple driven stakes, it says, shall be not less than 16 millimeters in diameter. Rebar, 16 millimeter rebar or 16 millimeter steel or whatever. 12-month life. And then goes to talk about the bouncy castle, that the anchor points shall have a minimum braking strength, so that you don't want the bouncy castle to break. In operation up to 40 km/h winds. The anchorage system is such that people don't trip over or get injured on the stakes themselves, so I guess at a public event you have it fenced off or something like that, or something to cover them. The anchorage system should be designed so the anchor ropes or straps are secured in a manner that prevents the device lifting off the ground, which is what it said. It needs to do the job. And, tied properly, etc., etc. This is the really crucial part. The rest of it is kind of irrelevant. There's a diagram showing the anchor points, etc., and the way the forces are done. And minimum design loads for device anchor points, etc. At the end of the day, most bouncy castle people are going to find an anchor point, take the peg they've got, and put it into the ground. That's it. Just note that for the ones that are on the ground, the normal anchor points, they need to be able to take the equivalent of 160 kgs sideways and 0.5 kilonewtons. So 50 kgs equivalent pulling upwards. This is where the deformed bar, the rebar, whatever you want to call it, has a bit of an advantage over just plain steel because they tend to be more resistant to just lifting straight up. If it's a guide rope coming down, obviously then that's a steeper angle. It's not just a pulling sideways type thing. It's pulling up at some angle or whatever. Then it needs to have more of a vertical component, obviously, because that's what the thing's doing. And so for 50, 60 degrees, which measure to the ground, so 50, 60 degrees up or more, those ones need to be able to take at least sort of 300 kg force pulling vertically upwards. That's a lot of force to be pulling vertically upwards. Also means those pegs have got to be put in definitely at an angle. I would say at right angles to the rope. So whichever way the rope's pulling, peg goes tangentially to it, at right angles to it. Normally the pegs you put in just on the ground just go straight down. They don't go straight down because they always slope as you hit them, etc. But near enough going straight down like that. If you look at the diagrams, which you can't see because I can't reproduce them, it's kind of obvious, but if you've got guide ropes on a slide, for example, or bouncy castle, then really you want them going out as far as possible so that the angle to the ground is as small as possible, and that way your stake in the ground, your peg, doesn't have to take as much vertical force as it would do as if it was almost straight down. Because imagine if you had a guide rope and it just went straight down, all the force is straight up. So it's the vertical force, and you couldn't put a peg horizontally into the ground to do it. So you want it as far out as possible. We try to. Obviously, sometimes that's looks a bit weird. Ropes going right out, and yeah. And if you're in somebody's garden or something like that, space might be a bit tight. The best thing I can recommend is if you have a slide, something like that, is to park a vehicle or a trailer next to it, either side, and tie down to that. It isn't going anywhere. The truck, the trailer are not going anywhere. Here's another thought of weights against pegs. We prefer to put pegs in at all times. They're just stronger because we don't carry 2 or 3 tons of weight pegs around to hold down bouncy castles. We put down sort of a normal amount, maybe probably 30 to 60 kgs on each corner, that type thing, or in the middle as well. If a peg becomes loose, then it's as soon as it becomes loose, it is absolutely no use whatsoever. None. If a castle gets pushed sideways slightly and it's got weights on, the weights still do their job. I can't imagine a bouncy castle flying away with heavy weights attached to it, even if they're not 1.2 tons. It may slide, it may rock and roll or do something like that, which is all scary and shouldn't happen and should have deflated by that time, etc., etc. But I don't think it's going to fly away. Perhaps very small weights, yes, because you imagine small weights would be the same as, just having a small child on it or something like that. But they tend to keep it down, try and keep the edges down to stop the wind from getting underneath. That said, I'd still use stakes every time if I could, because they're just so much stronger. So for Anchorage, we supply or use 2 types of pegs. First one is here. That's 30 centimeters, 300 millimeters rebar, 16 mil diameter. Or we have this peg here, which is longer, 400 millimeters length, still 16 millimeter diameter. And we've produced a separate video where we've tested them out in the garden. The strength of your peg depends so much on the ground conditions. Whether it's raining now, I don't know if you can hear it on the roof. If the ground is very wet, then they depend on the soil. That will be much weaker, and so pegs will tend to rip through a lot more easily. If we go closer to the beach from where we are, the soil becomes a lot sandier. Just very, very little strength in it. Where we are, we have a sort of layer of soil, and then we're into stones, and lots of stones. Where you are, the soil may be clay or whatever, etc., etc. We did a test for where we are. A lot of the bounce castles we put up are local, so the conditions are similar. As we'll get to further in the standard, it does say that for each setup you should test a peg. Yeah, that's not going to happen, is it? No, you're just going to put the pegs in, aren't you? Yeah, we all do.